Hello everyone, welcome to today's video on light basics and the electromagnetic spectrum. So, we're pretty familiar with light. We've seen it our whole lives. It's been a very important part of every day and literally minute-to-minute functioning. But there's actually a lot to it. So light is actually made up of photons. Photons are these little energetic particles, and they actually have no mass. Now, that's a really, really strange idea that light actually has a particle, but it doesn't have any mass. But we're just going to kind of roll with it for now. If you want to debate the idea of a photon later, I'll be happy to. Photons move in a wave pattern. So it is a actual particle that moves in a transverse wave at varying frequencies and wavelengths. Electromagnetic waves compared to longitudinal waves and mechanical waves, they do not need a medium because it is a particle. It kind of is its own medium, if that makes sense, because the photon is the wave. So that's why light can travel through space while sound cannot, because there's no medium. But light doesn't really even need it in the first place. Light is very, very fast. 300,000 kilometers per second. That means in 1 second, a photon can actually travel the circumference of the Earth 8 times. Wow. Light is much, much, much faster than sound. In fact, it's around 900,000 times faster than sound. Wow. So if somebody asks you the speed of sound or the speed of light, which one is faster? The speed of light is absolutely faster. In fact, the speed of light is frequently considered the speed limit on the universe. We have never recorded or observed anything that travels faster than the speed of light. And anytime we think we do, there is some kind of glitch. Now, electromagnetic radiation is light. Okay, so if we're talking about electromagnetic radiation, we are talking about light. If we're talking about light, we're talking about electromagnetic radiation. And the biggest source of electromagnetic radiation is the sun. It actually emits the full electromagnetic spectrum, which is what we will spend the rest of this video on. And we can only see, I'll show you, I think it's this next slide, the amount that we can see is a very, very, very small amount of it. But the things that we cannot see still can definitely affect us, and that's what we're going to learn about today. Here is the full electromagnetic spectrum. So you see that little tiny colored portion in the middle right there? That is the entirety of light that we can see. Everything else in gray, we cannot see with the human eye. There are animals out there that actually can see some of these different, a little bit outside of the human visible spectrum, so maybe that should be rephrased a little bit, such as bumblebees actually can see UV, and they kind of use it as a marker to see which flowers have been visited or not. And just the amount of the spectrum that different animals can see is dependent on what's kind of useful for them. And let's dive in. We're going to start way at the bottom, all the way on the right if you are keeping score. With radio waves. These are the least energetic. We're going to go over 7 categories. So if we're ranking them, this is number 7. They are very low frequency and have very long wavelengths. If you look at the wavelengths on the bottom, it says 10 to the 8th meters. That means that these can be actually kilometers long for just one wavelength. They're used for long distance communication. When you hear radio waves, you think probably the radio in your car, and yes, that's exactly what they're used for. Sometimes they're used in satellite communications, just mainly communications in general, they're really good for. Next up, we have microwaves, a little bit more energetic than radio waves, but still quite low, so it's number 6. They are low frequency and long wavelength as well, but these ones do start to get under a meter. Obviously, you think of microwave, you think of probably the microwave in your house. And yes, it is used for heating food, but these also can be used for communication. Infrared radiation. Now, I want to point out it's not infrared, it's infrared radiation, is somewhat energetic. Number 5 on our whole list. Relatively low frequency, and the wavelengths are getting quite short. They're used for heat-sensitive thermal imaging. If you've ever seen IR imaging, where they're heat mapping something, that's what they're using, is infrared radiation to track it. Security cameras also very commonly use infrared radiation. Now, the visible spectrum. In terms of energy, this is right in the middle, number 4. Medium frequency, medium wavelength compared to the other ones. And this is the reason that we can see things. We are going to spend a lot more time on the visible spectrum and why we see colors that we do. Did you know that colors actually mix also? Kind of like we mix paint, but they follow a little bit different rules, but we're going to get into that all later. Ultraviolet radiation, this is definitely energetic. It's higher frequency than the visible spectrum, and it's shorter wavelengths. This is actually commonly used to sanitize products. Hospitals use these a lot for things that they need to be really clean. They kill microbes, and we want to really make sure if we're performing surgery on someone that the things are clean. This is also the reason that you get a sunburn. If you go outside, you get a sunburn. It's not the visible light or anything like that. In fact, if you had something just emit the visible light spectrum and you hung out outside of it or right under it for a long time, you're not going to get maybe you'd get a little tiny something, but you're really not going to get a burn. It's the UV radiation that causes sunburn. The good thing, even though the sun does emit this, the very high energy ultraviolet radiation is actually blocked by our atmosphere. So even though the sun emits the entire spectrum, not all the spectrum necessarily gets to the ground. And you'll see in our next couple that is a very good thing. X-ray, highly energetic. This is number 2 on our list. It's high frequency, short wavelengths. And we do have practical uses for it. We use it to see in the human body. If you've ever had a broken bone or something like that, bones absorb X-rays, so we can use it to capture an image inside. It's also used sometimes for cancer treatments. However, if you're exposed to X-rays in a non-controlled manner, it can cause cataracts. That's stuff that goes on in your eye if you get X-rays directly to the eye. You can get burns on your skin, much like UV, but they happen a little bit faster, or it could cause cancer. So yes, it can be used to treat cancer in the right doses, but X-ray radiation can also cause cancer itself. And luckily, this is one that is blocked by the atmosphere. So we do not have to, well, UV radiation can cause cancer. We know melanoma, skin cancer, stuff like that. But X-ray is more dangerous, and luckily that is blocked by our atmosphere. So you do have to worry about, make sure you wear your sunblock, but you don't have to worry about X-rays when you're going outside. And our final one, gamma radiation. Now, I'm sure you hear gamma rays, and the first thing you think of is the Incredible Hulk. Sorry to burst your bubble, but Dr. Banner would be quite dead if he actually was exposed to gamma radiation the same way that he was in the Marvel movies. I love them, but not really reality. They are very high frequency, very short wavelengths, and they are also sometimes used for medical treatments and sanitation. But in particular, they're used in nuclear power. When we're talking about nuclear energy, nuclear bombs, things like that, this is what we're talking about. This is very, very high energy. Can cause damage to your bones and your organs, cause cancer, and radiation poisoning, cause nausea, vomiting, all those kind of things. And this all can happen pretty quickly. Things like UV light, going back to that, right? You go outside. Usually it's not 2 minutes outside and, oh my goodness, I have a sunburn, right? It takes a little while, unless you're fully exposed. Could be 15 minutes or so and you start to get a burn. But something like gamma radiation can be seconds, and you can get some of these negative effects, okay? And very luckily, again, this is blocked by our atmosphere, so you do not need to worry about gamma radiation just walking outside your house. This is also the reason that things like Chernobyl and other radioactive contamination is so dangerous, is it lets off gamma radiation. And why in space we actually have to have a bunch of protective shields, because then you're fully exposed to gamma radiation and can be very damaging. Okay, I know I threw a lot at you today, but that is our summary of the electromagnetic spectrum. We will be working with this a bit more, so don't panic if you don't have quite the grasp on everything. But I just wanted to give you a little bit of an intro to light in the electromagnetic spectrum. All right, everyone. Hope you're having a great day.